In this video, we'll be finding the inverse of exponential and logarithmic functions. Now, we've talked previously about the inverse relationship that logarithmic functions and exponential functions have. And we've talked about the fact that those common bases undo each other. So as we're working and finding inverse functions today between logarithmic and exponential functions, we should be expecting the following to happen. When we're finding the inverse function of a logarithmic function, we will expect it to end up with some sort of exponential function, because the only way to undo a logarithm is to use an exponential. And then vice versa, when we find the inverse of an exponential function, we'll expect it to be some sort of logarithmic function, because again, logarithms undo exponentials, exponentials undo logarithms. So if we're going to be finding the inverse, we're going to have to be undoing the operation that's currently in the function to its inverse, which is going to be, a logarithm if it's an exponential and an exponential if it's a logarithm. Now, a couple of key things to remember. Remember log base nothing. You can know that it's implied to be log base 10 if there's no number there. And then remember that the natural log is always base e. So you can always assume that it is base e. Just kind of keep that in the back of your mind as we work. So let's jump right in and find the inverse functions of the following. So remember, when we're finding inverse functions, what we're going to do is we're going to switch x and y and then use whatever properties necessary to rewrite that equation for the new value of y. So let's start here with problem number 1. We see that we're going to start off by writing this as y equals 6 to the power of x, because we need to have it in terms of y and x. And then we're going to switch x and y. So we have x equals 6 to the power of y. Now, we don't really have a good way to get the y out of the exponent here, but we do have a property that we've talked about before, how if we have log with a base and then we have x equals y, we know that we can rewrite any logarithm as an exponent by changing that to b to the power of y equals x. Remember, the bases stay the same, but then the x and the y flip which side of the equation they are on. So when we're finding these inverse functions, we're going to use this property that we've looked at in previous videos to our advantage. We're going to be able to rewrite logarithms into exponents and exponents into logarithms. So here what we're going to do is we're going to rewrite this exponential function into its logarithm equivalent. Now, if you like it to be written in the same order as these, you can actually write this as 6 to the power of y equals x. It doesn't matter. It's up to you if you like to have it written like the property is written. So what we're going to do is we're going to now rewrite our exponential, because that's what we have, into its logarithm. So here we're going to take logarithm of base 6, because that's the base of our exponent. This is going to go inside of the logarithm, and that's going to be equal to what was in the exponent, which is y. So our new function here, which is the inverse of f of x equals 6 to the power of x, is log base 6 of x. Now if we jump over and we look at example 2, this one we notice we have a natural logarithm. So as I rewrite this, I'm going to write y equals natural log. I'm going to write the little e in there to remind myself that natural log is base e. And then I have x plus 3. Now in order to find the inverse, we start by switching x and y. So we have x equals natural log of base e, y plus 3. And our goal is to eventually rewrite this so that we have y by itself. So what we can do from here is we can use these properties again. Remember that log base b is ln base e. You can use the same properties with them, which is great. So here what we're going to do is we're going to rewrite this logarithmic equation into an exponential equation. Now our exponential equation is going to have base e, so I have e to the power of what's on the other side of the equation, which is x. So e to the power of x is equal to what's inside of the logarithm, which is going to be y plus 3. So this looks a lot easier to solve once we use this property right here that allows us to rewrite exponentials into logs and logs into exponentials. Now from here, the last thing we need to do to get y by itself is subtract 3 from both sides. So we end up with y is equal to e to the power of x minus 3. So in both of these situations, we started off with an exponential or a logarithm, and the function we ended up with in our inverse actually contains the opposite one. So if we started off with a natural log, we have an exponential. If we started off with an exponential, we end up with a log in our final inverse functions. So let's try 2 more examples here. And again, remember, we're going to use that property of log base b x is equal to y, and then you could have b to the power of y is equal to x. So remember, this property of logarithms and exponentials is going to come in handy here and allow us to rewrite logarithms and exponentials as we find their inverses. So let's take a look at example 3 here. Let's start by writing this in terms of y instead, and then let's switch our x and y so we can find our inverse. So we have x is equal to 5 to the power of y plus 3. Now in order to rewrite this for y, we know we're going to need to utilize this property here and rewrite our exponential into a logarithm to try to get y out of that exponent. So we know that our exponential has a base of 5, which tells us that our logarithm is going to have a base of 5. Then from here, whatever it's equal to, which in this case is x, is going to be what's inside of the log. So here we have log of base 5 with x on the inside is equal to what was in the exponent, which is y plus 3. So now from here, we're very, very close to being done. All we need to do is subtract 3 from y on each side to get y by itself. So we end up with the function y equals log base 5 of x minus 3. So that's our inverse of our original function there. Finally, let's take a look at this 4th one. So here we can see that we have a logarithm. So I'm going to start off by writing y equals log of base 5 2x minus 5, and then I'm going to switch my x and y. So I have x equals log base 5 of 2y minus 5. So from here, I'm going to rewrite my logarithm into an exponential. Because my logarithm has a base of 5, my exponential is going to have a base of 5. So I have 5 to the power of what's on the other side of the equal sign, which is x. And that's equal to whatever is inside of the log here, which is 2y minus 5. So I rewrote my logarithm into an exponential using that special property in their relationship. Then from here, I simply need to rewrite this so y is alone. So I'm going to add 5 to each side. 5 to the power of x and 5 do not combine because the first 5 has that power of x attached to it. So now I divide by 2, and I end up with the function y equals 5 to the power of x plus 5, all divided by 2. Now the last type of example I want to walk you through is what happens if the logarithm or the exponential aren't by themselves. So say you have something that looks like y equals 7 to the power of x plus 4. Or say you have something like y equals log base 2 of x minus 3. If you're in this particular situation, yes, you start off by switching your x and y. So in each of these, it would be x equals 7 to the power of y plus 4, and it would be x equals log base 2 of y minus 3. However, in order to undo the logarithm or the logarithm or the exponential have to be by themselves. So in each of these cases, you would need to make sure that you take the time to rewrite your expression a little bit further before you try to undo the logarithm or the exponential. So for example, in the first example I have going on here, I would subtract 4 from each side. So I would have x minus 4 is equal to 7y. And then here I would have x, you'd add 3 to each side. So I'd have x plus 3 equals log base 2 of y. And then from here you could rewrite these using your inverse property or using that logarithm exponential property. So here this would become log base 7 of, it would be x minus 4 equals y. And this one would become 2 to the power of x plus 3 is equal to y. But notice that I had to get the piece that had a logarithm or an exponential alone first in order to use that property where I can switch between log and exponential. So make sure it is alone before you use the switch for log or exponential.